for Prefect users, it's an exciting week because we announced basically Prefect 2.0 this week, and it will be covered a bit in this meetup. But also, I will detail like some upcoming events on the Prefect side that will like explain more about what we have in store with Prefect 2.0. So yeah, with that, let's get started. This shouldn't be machine learning. This is more like just general purpose data orchestration. Um, all right, thank you, Tyth. So about me, I am a open source community engineer at Prefect, which means around 80% of my job is handling Slack questions, like supporting Prefect users. And we have a variety of use cases. So a lot of our Slack questions will be like, how do I run this workflow on like AWS ECS? How do I run this on Kubernetes? So there's like a variety of things, variety of setups that you can have with Prefect, and we help people like integrate Prefect with their setups. And if you're not familiar with the workflow orchestration space, that's totally fine. We'll go more over it. We'll go over it more in a bit. Prior to joining Prefect, I was a data scientist myself for 4 years, and in that 4 years, I worked for 2 companies. One was like an electric utility, and the second one was like HR and payroll. And I found myself doing a lot of the deployments, a lot of the like data engineering components, so that we could accelerate our team. And that's what made me particularly interested in workflow orchestration. And then I found out about Prefect eventually. Outside of Prefect, I have another open source project I work on called Fugue. Fugue is a unified data frame interface for Pandas, Spark, and Dask. So I guess I still work on some data science tooling. And then outside of those, I am also a meetup organizer. I organize the Orlando Machine Learning Meetup. So with that, for today's talk, we'll go over these 4 things. Number 1, we will talk about workflow orchestration, just a general purpose like overview of what workflow orchestration is if you're not familiar. And then we'll show how you use Prefect to orchestrate a workflow by going hands-on with a simple problem. And then we'll discuss how Prefect and Dask can be combined to leverage distributed compute for parallel execution. And then lastly, of course, we have the Orion updates and the future of Prefect. So Orion is the name of Prefect 2.0, and we'll discuss that a bit here. And with that, let's talk about workflow orchestration in general. You're always free to type questions in the chat if ever anything doesn't make sense. So with that, let's start with a general machine learning pipeline. The machine learning part isn't the important part here. The important part is on the left side. We have, a Postgres database. We have a REST API. We have to query the REST API. We get data from the database. Output them in certain files. We join the files with Pandas data frame library. We output it to our model, machine learning model training, and MLflow is to like persist artifacts related to that training or have experiment tracking. And then we have Flask, like we can deploy our model to a Flask API. And if you look at this pipeline, like this is a very standard like machine learning workflow that maybe this is a job that runs every month or something where you continuously retrain your models so that they are always up to date and always work on the latest data. So this is something that you'd schedule every month. But like if you look at this entire pipeline, you can really see that there are certain stuff that depend on other tasks succeeding, right? Like, for example, this Pandas portion here, it's really dependent on the API call working. Your model training has to succeed in order for you to be able to persist artifacts from it. Model training can fail very commonly, like especially with like deep learning stuff. We find a lot of people running into like out of memory issues, or maybe you just have other errors with the data being malformed. On the upper hand, like your databases can also, queries can fail, queries can time out, database compute can go down. And the point of this is that in general, there are just so many ways that a standard data pipeline or even a standard workflow can fail, right? And these things may not even be within our control. especially when we're talking about APIs hosted by other vendors, or when we're talking about maybe you didn't get your spot instances needed to run something. Like there are things inevitably out of our control, and there are many points of failure. So workflow orchestration then traditionally is we have this DAG, right? So this directed acyclic graph of dependencies. And workflow orchestration is about managing those dependencies such that you can say, oh, if this particular task fails, then don't continue the downstream ones. Or if this particular task fails, maybe you can just retry it again. Maybe it will succeed, and then you can go on. Maybe if something fails, you want some like extra monitoring, observability, logging, or notifications, anything along those lines. But at some point, eventually, as engineers, we tend to spend more time on the defensive engineering, where we are continuously coding against failure, right? So we're always handling failure. And in Prefect, we call that negative engineering, right? And the point of when we talk about negative engineering, we're talking about the things that are not really in your job description. Like if you are a data scientist, you're really there to make models. You're not there to, ideally, you're not supposed to be spending a majority of your time on this defensive engineering, right? And when we talk about for one pipeline, we already saw there were multiple, for one pipeline, we saw there were already multiple points of failure. For an interconnected pipeline, because in a real like data organization, you share pipelines to avoid recomputation. You have common components across your pipelines. And when you have interconnected pipelines, these dependencies, you have to, it becomes significantly harder to manage them. And here on the top side, we have a BI pipeline. On the bottom side, we have our old machine learning pipeline. They share, common files. What do you do? Like if this REST API fails, maybe our whole top half can still succeed, right? So workflow orchestration is about managing these dependencies and making sure that your pipelines behave the way you want them to. And Prefect was found to eliminate negative engineering, right? So there's a question here by Nick. Did Prefect or Chris White or Jeremiah, so Chris White is our CTO, Jeremiah is our CEO, did they coin the term negative engineering, or was it already out there? To my knowledge, and I tried searching for this, if you type negative engineering in Google, you do arrive at the Prefect blog post that described negative engineering and said that Prefect's mission is to eliminate negative engineering. So I would say yes, it is a Prefect term. And it's a very good term because it really encompasses our mission and what we try to do. So, I don't know if this is still true, but even as like a data scientist, you would always hear something like 80%, 90% of the job is just cleaning the data, transforming the data, doing the boring work, right? Quote unquote boring work, right? And if you think about it, that 90%, 80 or 90% of your data scientist time is spent on negative engineering, that means that if we can reduce 90% to 80% or 70%, then you can double or triple developer productivity. So Prefect's mission is to reduce the amount of time developers spend on negative engineering. And this means for Prefect, this means giving you the tools that allow you to set up this defensive engineering much faster. So for example, you can have observability into your tasks. You can configure retries easily. You can configure notifications easily, give failure logic. So if there's malformed data, your flow knows what actions to take. And in general, we give extra, what you are getting when you pay for Prefect is the observability. And with that, I'll introduce Prefect to you. So Prefect is both a business and the open source tool. Currently, we have 7,100 plus. It went up again today on GitHub, 7,100 plus GitHub stars. And our Slack community is around 9,000 strong now. We are an open source workflow orchestration tool, Python based, and designed specifically for the modern data stack. So we want to be the data tool for the modern PyData ecosystem. And because of that, we have a native Dask integration. Uh, and I guess we'll learn more about that from Richard here, where you can have like, you can use Dask as your executor to parallelize your prefect flows. We have a very active community, so I manage the community myself. I'm always there answering questions, even if you want to chat about workflow orchestration in general, you want to compare us to another tool, get some feedback, and Prefect do this, we're always happy to chat. Of course, in some cases, we also say, Prefect is not meant for that. So Prefect is primarily meant for batch processing. It's not really meant for streams. So that's a very clear one. And Prefect really, when you use Prefect, there's two components to it. Number one is the Python client where you define your flows, which I'll show, and that's called Prefect Core. And then when you use Prefect Core, you define your flows and you run them eventually against a backend. So the backend will be Prefect Cloud or Prefect Server. Prefect Cloud is our managed version of that. Prefect Server is an open source version of the whole stack that you can deploy on your local infrastructure. A lot of people do indeed just run Prefect Server all the way. But you should all know that if you wanted to try Prefect today, you can literally sign up for an account. I believe no credit card needed. And Prefect Cloud gives you 10,000 free task runs every month, which is way more than enough to get started with. So everyone can start using Prefect Cloud for free. This is just a sample of what the UI currently looks like for Prefect Cloud. So you go into the dashboard, you see the green are the successful flow runs, red are the failed ones. This is interactive. I can click into them, see why they specifically failed. I could check the logs for them, see which task runs actually failed in them. And I also so when you go into the dashboard, you can see, a lot of our clients refer to this as the single pane of glass, where they can see everything in their organization, see what failed, what needs to be rerun, what needs to be fixed easily. In fact, we actually even had requests in the Slack channel to make this mobile friendly, because some people wake up in the morning and check this on their phone, and we actually will make that. We will be mobile first in the future. So yeah, today I said I at the start I said that this is a big week for Prefect because we had two major announcements. Number one, we acquired a company named Slate Data. Slate Data is a consulting firm that handles a lot of infrastructure, and they will be in our support. So we expanded our enterprise support offerings. And number two is Orion. So Orion is Prefect 2.0. And if you saw the title that Nick had today, it was like eliminating the DAG. And that's because we find that the DAG is an archaic representation of workflows that is constraining in a lot of ways. When you have a DAG, it means this directed acyclic graph of dependencies. It means you have to, in old orchestration workflow tools, you have to pre-build this DAG, and that DAG has to be followed. So there's no dynamicism, right? And because you have this predefined DAG, you ahead of time need to know everything about what's going to happen to your flow. But with Prefect 2.0, we eliminated the DAG because we found that it is more limiting, it's archaic, and we'll talk about a bit more of the history of that in a bit. And by doing that, we're injecting less and less Prefect code into your workflows. So just a quick snippet of Orion, and this will be the 2.0. So if you leave today's talk without anything else, just know that this is what Prefect will look like in the future. So notice that there's a task decorator and a flow decorator. The flow decorator, it's a very non-invasive setup to your code, in a sense that you're just all the Prefect code here is in this task and in this flow, right? And everything else is very Pythonic and very free of any Prefect dependencies. So we want to make the developer experience as close to native Python, and it feels like you're just using Python functions as possible. And so when we talk about the DAG-free workflows, we find that if you look at the history of workflow orchestration, they used to be defined in YAML files. And because they were defined in YAML files, they have that sequential top-down structure. But now that as we're using programming languages and these coding interfaces to define workflows, we have more freedom to have and not be constrained by this DAG. And with that, I just want to clarify. So what I showed was Prefect 2.0, but it's still not recommended for production use cases. So still today, if you use Prefect today, you're still going to use the traditional Prefect core, and that's what I'll be presenting today. This Prefect core is like our production-ready offering. So for our problem today, we're going to be tracking Dogecoin prices, and I just want an alert whenever there's a dip. When I was preparing this talk, the core of this talk back in May for the Dask Summit, there was actually a massive crypto dip, which was kind of funny. Like literally 10%, Bitcoin went 10% down everywhere across the board. So yeah, so some people, they see these as signs to buy and they want to monitor these dips. So for our Dogecoin tracker, we basically have 4 steps. Number 1, we're going to construct the URL, and then we'll do an API call, get data, and then check if there's any dip in the data. And if there is a dip, then we'll get a Slack notification. So first, this function, all you need to know is that this is the URL we're hitting. Then we're just giving parameters to it: start time, end time, and the coin that we are loading. And then this get data function just uses this URL with a coin, so Doge, BTC, Ethereum, gets a Pandas data frame with this request.get and returns that Pandas data frame. The next step is detecting if there's a dip. All we're doing is using the maximum, the minimum values of this time series. We just check what percent of the maximum the minimum value is, see if that's above a certain threshold. If it is, return true. If not, return false. There's no dip. And then the last part is the Slack notification. This one I won't write Python code for because this is one of the things Prefect significantly makes easier to do. So I'll show that later. And now that you are ready to bring this into production, without any workflow orchestration tool, what you would do is you'd probably make an infinite while loop, right? And you just say, hey, every 5 minutes, run this sequence of functions, right? But this is, of course, unstable for production, right? What happens if the API fails? What happens if we wanted to parameterize it? We'd have to, take out this. We'd have to edit the function, run another Python process. What happens if we wanted off-schedule runs? I wanted to run it now. I'd need to make another Python process also, take out this while loop. And then lastly, we want notifications if the run fails. So we still need to address this post to Slack. And with that, we'll bring it to Prefect. So in this simple example, we'll be focused on retries and parameters and this Slack notification. So all this code will be familiar except for the green highlights. And in Prefect, the semantics for workflow orchestration are flows and tasks. So flows are more like entire Python scripts that group a lot of tasks together, right? So tasks are more like functions. Flows are like scripts that combine a lot of functions. I'm just adding this task decorator here, and I can now use it in a flow object, right? So here I'm saying with flow, and this is my flow name. And now I just call them as if they are Python functions. And then we do flow.run. And there's 3 interesting things here. Number 1 is that there is a first class passing of data between tasks. So we have data here, and this is the result of this task, and it gets fed in here. And then number 2, because of that, the get data is automatically upstream now of the detect dip, right? So we automatically have a setting of dependencies in a very Pythonic way. And the last one here is flow.run. So flow.run runs this as if it were a Python script. This is important because other tools require you to set up a lot of infrastructure just to run a local test. Whereas because this is just, I mean, this is already Python, we can just call the Python underneath, and we can just use flow.run for local testing. So local testing is a big feature also, and it improves project iteration time. Next, we have an API call, and API calls can fail due to outside, like even if it's not our own fault. So here we can define that, hey, if this fails, just retry it and try it a maximum of 3 times, and each of them with a 1-minute delay. So now this task, if ever we fail to get data, we will still, we'll just retry it, and it will if it reaches the 3 tries and it doesn't succeed, then our task will, only then will our task fail. Next thing is parameters. So a while ago, this coin takes in a string. So now we can parameterize this by adding this parameter. So the prefect parameter is just a special task. The special task just injects a value during runtime. So now we can pass in, hey, run this flow with this certain parameter, like with Bitcoin or with Ethereum instead. And now this entire logic will run with that parameter given. So now I can also test my flow.run with the new parameter. So I can say flow.run, and I pass in a dictionary of parameters, and I can say run with Bitcoin. And now all of this will run with Bitcoin. And the last thing I mentioned was posting to Slack. So this is much easier to do with Prefect because of our task library. So because everything I've shown you and tasks are just written in Python, all you have to do is wrap like an API with our task decorator. I mean, you could wrap it with a task decorator, and it essentially becomes a task that you can bring in to a prefect flow. And a lot of the tasks, like PostgreSQL, MySQL, these are tasks that are very standard. Normally, you're just querying something, getting the data. Databricks, you're normally just starting a Databricks job. AWS, well, this one has a lot, but like a lot of people just interact with S3, getting data, pushing data there. And because a lot of these tasks are very standard, we can have a task library with pre-built tasks that a lot of people can just go in and use readily for their flows. Around 85% of our task library is community contributed. And like we do have community members active, and we have partnerships also with some of these companies where we are working together to make more integrations. So for today specifically, we will be using the Slack task, and this just sends a message to Slack for us. So to give you an example, all I'm doing is importing this Slack task, and then I can just give a Slack. I can just use it inside my flow with this message and with a webhook. And the webhook is where to send that message to. So I have a webhook URL that I pre-configured, and I'm giving this message. There's been a dip in Doge price. But of course, this is a secret that value that has to be secured in some way. So you can store your secret values in Prefect Cloud, or you can use them locally with environment variables. All that we're doing is we have a predefined secret. We have a predefined, this Slack task will look for the secret with this name on Prefect Cloud, because just because that's how it's coded. But you can also load secrets from within a flow. And this secret will now be used for that Slack task, so that now wherever you're running this, it'll just query Prefect. As long as you're authenticated to Prefect Cloud, you're going to query, get that secret, and then use it in your flow run. The last part to I think this is the last part, to migrate our flow from the native Python to Prefect is we need this conditional logic. So if there's a dip, post to Slack. So for us, we just use this case, and this is an if else. So if there is a dip, if is dip equals true, then we post to Slack. And now with that, we are ready to register our flow against Prefect Cloud. So all you have to do is replace your flow.run with flow.register. and you give a project name, and now this is registered against Prefect Cloud. And then when you register, you can attach a schedule to your flow optionally. You can also just, run it ad hoc. But here we have the semantics for scheduling are, we have clocks, and we have these we have filters and adjustments. So in clocks, you can use a cron clock or an interval clock. We actually have a new clock fairly recently, which is like the RR clock, which is like the iCalendar rules that was community contributed. So here we define a clock and an interval with this interval clock, and then we just say the parameter default is for Dogecoin. So now if I wanted to just make like 3 separate coin runs, I can do it by setting 3 different like clocks, where I can say clock 1 is Dogecoin, clock 2 is the Bitcoin, clock 3 is like Ethereum, and I can run them concurrently. And then filters and adjustments. Filters are like, hey, run this every day, but not on these days. And then you would just filter those times out. Adjustments are like, hey, run this every like 15 days, but if it's a Sunday, run it on the next business day. So with these 3, like, you have enough power to control your schedule. You have a lot of flexibility and power to control your schedule. And with that, we'll do a quick demo of Prefect Cloud. I have the code already here, which is basically what we described. So you have this Doge, this flow that checks for dips in the Dogecoin, and I am going to register it with my Bristech project. So in order to do that, I just run this script. And I should see, I'm already authenticated, so I should see, oh, this got registered on Prefect Cloud. And then we'll go over to Prefect Cloud, and I'll just start in the general dashboard, and then I'll go over to flows and open this. I have a Bristech project, and our flow was called to the moon. So we should see to the moon here. And from here, I can just do the quick run. But before I do the quick run, I just want to talk about the Prefect agent. So the agent is a lightweight, long-running process that sits on your infrastructure and pulls Prefect Cloud every 10 seconds. So if it says, hey, there's a flow, then it'll pick it up and take care of running it. So what I'm first going to do is hit this quick run button. And what you'll see is that there will be a scheduled run. It's going to have a yellow bar soon there. And this is scheduled, but it's not running. And that's because there's no agent to pick it up yet. And then we get this clock, oh, it's already late. Like this is not running. So now if I spin up the agent, this agent will pull Prefect Cloud, find that, oh, there's a flow to run. And then now this bar is changing, right? So this bar will go from yellow to blue. Blue indicates that it's running. Green means it successfully ran. And we know it successfully ran because I should get a Slack message. So
I think we've got a problem with Kevin's connection there. We'll give him a second, see if it comes back.
there has been a dip in. Hey, am I back?
Yeah, sorry, you just dropped out for a second there. You're back again.
Is my screen still sharing?
Yeah.
Okay. So yeah, so we had the flow that ran successfully, and now we the agent picked it up, took care of executing it, and this is a very important part of Prefect. We don't know anything about your code, about your infrastructure, or your data, because everything is on your infrastructure. So my agent pulled Prefect Cloud and said, oh, there's a flow to run. So it took care of running, like the agent itself started that process and took care of running it. Am I still cutting? Oh no, okay, I'm good. All right, and So because of, and this is what we call the hybrid model. So Prefect does not see any of your information at all. So we have a lot of clients in the finance industry and the healthcare industry that really like use Prefect because of this. And with that, we'll go back. So just to recap, we went over flows and tasks. We went over parameterized flow runs. We had retries. We went over the task library. We used the Slack task from the task library. We used the secret stored in Prefect Cloud. And then we talked about registration and scheduling. And now I'm going to talk about Prefect plus tasks. I feel like I need to wrap up soon, so we'll just kind of go through this section quickly so that we can get to the panel. So Prefect plus tasks. Prefect was the founder of Prefect, Jeremiah, was actually part of the Airflow maintained like PMC, right? And Prefect came about because there was a list of changes that he proposed to the Airflow PMC that were rejected to make an Airflow 2.0, and that was rejected. And the basic idea was to, instead of using the Airflow scheduler, can we use the Dask millisecond scheduler to handle like task runs, right? Because in Airflow, they have a 10-second loop scheduler. So if you say, hey, run this now, it's going to run 10 seconds later, maybe. And there's still that 10-second delay between from task to task, right? Because the scheduler has to pick it up. It may have been, I think it may have been improved by now with Airflow 2.0, but the core idea of Prefect was how do we use the Dask scheduler instead to massively parallelize flows. Yeah, Airflow 2.2 was released recently. And if you're not familiar with Dask, Dask is a distributed compute engine. So maybe you're familiar with Spark. So Dask and Spark, they're along the same vein. But the important piece is that Dask, I think Spark right now is more data frame oriented, whereas Dask has a lot of data structures. Like you can have delayed functions, you can have the bag data structure, like the XRA. So there's like a bunch of data structures that allow for a lot more freedom when it comes to distributed compute. And that makes Prefect very general purpose because you can practically submit anything, any random function to the Dask scheduler, and Dask will handle the execution of that. So just a general overview, if you're using Dask distributed, what happens, and I got this from a GitHub issue on the Dask repo, you have a client. So this client is like whatever your machine is, and it's submitting work to the Dask cluster through the scheduler. And the scheduler is the one responsible for handing that over to the different workers. So because of this, Prefect will be the client passing over to the cluster scheduler, and the scheduler will be responsible for delegating that work. So now you can take advantage of this to massively parallelize like any task, any task that is like in if the tasks are independent. So this is where, for our example, and this is where Prefect kind of shines, where you have this dynamic DAG, although we are eliminating the DAG entirely in Prefect 2.0. Now we can give a list of coins and run them independently on those tasks, on those workers, and then collect the results, and then from there determine if we're going to post to Slack or not. So with that, we can do it pretty much without changing too much of the code. We just take in a list of our coins. Our functions were written to handle one coin. Now we just have to map over the list of coins. And then this is just a reduced step to get all the like true or false, and then the max of those will be true. So this is just to determine, was there any dip with any coin? And then if there was a dip, we'll post to Slack. Our mapping is also written in a way that does depth first execution, which is preferable in a lot of cases through Dask. And all that you need to do is change the flow executor. So we have the local Dask executor, which just uses all cores of your machine. And we have the Dask executor, which can take in a callable. So a lot of our users use Coiled to host managed Dask clusters that you can just spin up and then run your flow and then spin down. So Coiled has this software environment which builds your which is an interface for building a Docker container. And then you can just specify, hey, spin me up a coiled cluster with my software environment, shut down on true, and that's it. And if you use this, I won't demo this for the sake of time, but over here, you're going to see that it spins up the cluster. There's going to be 4 workers. It just runs your flow and then takes care of spinning it down. So now you can just on demand spin up compute, and your actual process running the prefect flow doesn't have to be like super heavyweight to take care of this because you're just sending work over to the cluster through the scheduler. And then lastly, the future of Prefect. I mentioned we have Orion, which is our Prefect 2.0. We have a couple of events. One is tomorrow, 4 p.m. If you want to talk about the 3 years of work that went, if you want to hear us talk about the 3 years of work that went into eliminating the DAG, like seeing how it was constricting and how we, more on what we can achieve without it. And just in general, the roadmap, like not the full roadmap, but just in general what the plans are for Orion. Then we have a meetup tomorrow. We also have this Orion Fireside Chat with Chris, our CTO, Jeremiah, our CEO, on October 22. And we also have this Prefect and Coiled joint webinar where Chris will be talking about using Prefect on Coiled this October 26. And I will send these links out all later. And then just a couple of resources. Number 1, Prefect Cloud. You have free 10,000 task runs for free. And then the rest are just please join our Slack community. I'm always there. I'm always answering questions. Feel free to chat. And then we have our documentation and how to use Coiled and Prefect together. There's documentation on the Coiled docs. And then just some Prefect docs. And with that, I'm done. Thank you.
Let's show our appreciation. If you could perhaps unmute, we'll say thank you. Thanks, Kevin. We have the occasional dog barking. We've had a parrot as well, but no such luck tonight. So if people have questions, don't worry about the chat window. Do people just want to unmute and ask the questions? And when we've dried up for questions, we'll vamp to the panel. So any questions from anybody? Maybe I can kick off. Like, is the Prefect server, so the one that's on-prem, is that hobbled in any way? Is it different in any regard from Prefect Cloud?
Of course, there are some features only available on Prefect Cloud. For example, automations like, hey, my flow hasn't run for 30 minutes, 30 seconds, or even like 1 minute, just cancel it. These require some services that only Prefect Cloud has. Authentication is another one. So these are services that have taken a lot of effort to build that are only available in Prefect Cloud and not in server, because server is a lightweight thing, and it's meant just for like a single team to be using, whereas Prefect Cloud needs the robustness to handle all of the deployments.
Okay, fair enough. Any other questions? Any burning questions from people? No, nothing. Well, if
I've got one.
Go on then. Go for it, Richard. Yeah.
So the Orion is news to me too, and as someone who works a lot with Dask, I'm just curious, if you're as Prefect is abandoning the DAGs, how does that affect the use of Dask, and are those related or?
Yeah. I would say they are slightly related. You can more closely interact with your Dask cluster if you choose to, because of the way Prefect wraps around your code. So you can just do your client.submit directly. I still think we will provide an interface for mapping that will like, you can still use Dask as the backend and then still parallelize your flow. So it's still there. It's still very much there. The interface may change a bit though.
Cool, thanks.
So maybe at this point we should actually go to the panel. I know we've perhaps gone a few minutes over, but that's fine for the talk. So I'd like to introduce Richard Pelgrim and Jared Rizor. So Richard, do you just want to give a really brief background in yourself?
Sure, yeah. I am currently a data science evangelist at Coiled. Saw a little bit of Coiled in action already. We provide hosted Dask clusters and API around that. It's a very short story, and I myself have kind of made a big career switch over the last year and a half. So this is a lot of this is new stuff for me, but I'm loving the vibe.
Yeah,
so,
congratulations on the new role. That's
thanks.
And Jared, do you want to declare yourself as well?
Sure. I'm Jared. I work at Airbite on the engineering side. We are an open source tool for bringing data from any sort of source, like files or databases or other warehouses, into your data warehouse. We want to make that easy and reliable, and something where all the fiddly bits of integrating with data sources are things that you can abstract away within our system. And since we're open source, you can run a server yourself, or you can use our cloud version, which we actually launched this week. It's a big week for us as well. And before that, I was in ad tech, working on like large scale data pipeline stuff that is exactly what you're talking about here.
Great. Well, maybe we can start to sort of join the dots in terms of Prefect Task and Airbite. I'd be very interested to explore that. But perhaps before we do, I've just got a couple of sort of questions, because I've been calling Prefect a deferred computation paradigm, which I guess is more to do with the deference of the computation through the schedule. Is that a phrase that Prefect would actually identify with, or am I sort of a bit wide of the mark?
I think that's right. I think because the registration is effectively a compiling or a build, and then you need to compile before you can run it. So if effectively, and then when you defer it, you can inject new data into your task runs, flow runs. So essentially we are a deferred execution. And there is that separation of build and runtime. Now, a lot of people have found this to be awkward for some certain use cases, and I think this is also one of the reasons we are going away with the DAG. So there is no awkward build run separation, and instead it will be a more organic, like one step, like you just run, of course on a schedule. Yeah.
Okay. And you mentioned there a couple of times sort of the tie-up between Prefect and Coil, which seems to be quite a strong relationship. Presumably that's been building over time, and potentially there's going to be a relationship too between Prefect and Airbite. Is that am I reading that correctly?
Yeah. So I don't know. Maybe we'll let Jared speak more to that. But on the Prefect side, and even I myself, I'm a big Airbite fan. Their growth has been phenomenal over the last year as an open source project. But I think you saw our task library, and our task library does give you some connections. But a company focused on building those connectors from sources and sinks that is open source is like, it I think goes hand in hand with Prefect, because you can use their library. Like managing the connections is a very, and especially the edge cases with those connections, is a very hard thing that takes a lot of effort. Okay. And if you can then expand the number of pipelines you can build by using Airbite, like by using Prefect to orchestrate Airbite.
So Jared, is that right? You're going for ubiquity of connector. That's the kind of like overlap here.
Yeah, exactly. That's the goal. To use the example from Kevin's presentation of like ingesting data from this API that's providing like Dogecoin values, our goal is to, first of all, have a very comprehensive catalog of open source connectors that allow you to connect to a bunch of different things. So like all sorts of like common data sources. So like we have everything from like COVID data sets to like Facebook ads data outputs. So it's something where we want to make it possible for you to either connect to existing data sources or easily implement connectors that can connect to a custom data source. And along the way, we want to handle all of the small pieces that are annoying, like retrying on rate limiting, the authentication configuration piece, handling like schema migrations over time. Like how do you know what to do when your API suddenly starts changing the format of its responses? So we want to make those easy to develop, maintain, and also have a catalog that allows you to select very common sources.
But right now, so at this point in time, if I'm connecting through to various sources, I'm going to be using the Prefect connectors, and there's no coupling between between actual projects. Kind of
there's no coupling yet, but I think it's very likely in the near future we'll have a Airbite task that would allow you to look at a specific connector in your Airbite instance. So like maybe you've configured a sync of a certain type and you're using that as an input to one of your Prefect flows. Then your first task might be make sure that my data is up to date in whatever I'm reading from, and then it will sync that. And with the API, it will coordinate to know when that sync is complete, and then you'll continue on your flow as usual.
Okay. And is Airbite batch as well, or is it actually a stream processing? Is it sort of between the two or not?
Our focus is batch now. Eventually we'll start doing streaming stuff, and we have some initial parts where we're doing like batch captures of streaming data sets. So like you can create a batch like selection of like recent stuff from Kafka, for example, but our focus is definitely batch right now.
Okay. And Kevin, I was just wondering whether Prefect obviously has the distributed nature of the the task processing. Would you say that it's mainly focused on in-memory use cases, and then you're spreading it across nodes for for that in-memory use case?
Yes. So one of the main distinguishers between Prefect and Airflow is the in-memory computation. And this is because if you look at, for example, Airflow's equivalent of the task library, their equivalent is what they call operators, right? And if you look at how operators are designed, because things are not handled like in memory, you need like the source and sink in one. Like their operators will look something like MySQL to S3, right? And it's very coupled, and you need to make all the permutations of all those sources and sinks. Whereas in Prefect, it's decoupled into like MySQL query, it's held in memory, and then you can push it to S3, right? So that also makes our task library more flexible. So yes, we focus on in-memory a lot, and the passing of data is also more efficient that way if you have the same data frame that's going through a workflow.
Yeah, because I think because one of the use cases that I've actually been using Prefect for, we actually turned off the implicit results and wrote everything disk, and then got around it that way. But I guess that's probably, we're not maybe using Prefect as it was designed, but it is possible, I guess, is what I'm trying to say.
Those result checkpointing are just persistence. If ever your flow has to restart from a point of failure, then it would be loaded from there. But that's not core to the flow running, and it can certainly run without it. Okay,
that makes sense. So Richard, I'd like to bring you in there, because obviously we've got this existing relationship, but people have a choice, don't they, of Dask provider. Could you sort of just give a little bit of the your sales pitch around why Coiled and how does it compare to other Dask providers?
Sure. Yeah. Yeah, so I think first of all, it's good to understand and talk about when you would even want to be using a Dask cluster. So I think Matt Rocklin, our CEO and one of the first authors of Dask, always says, if you can avoid working in distributed, please avoid it, because things get complicated. And if you can work with Pandas and NumPy, please do that. But if you don't, if you can't, and if you're working with data sets that are larger than your local machine memory, you have a few options. You can spin up a single large VM and run things there, or you can scale out even more to a cluster. And then you can either build your own. There's quite a number of different options of good open source extensions to Dask. Dask Kubernetes, Dask Cloud Provider, Dask Helm. There's a few different ones out there that you could use to run your own on-prem Dask cluster. Of course, that also means you need to buy the infrastructure, maintain it, maintain your own security protocols, things like that. And that kind of speaks a little bit to the reason why Coiled emerged, because a lot of people who were doing this basically begged Matt Rocklin to please build a company that could solve all the problems that they were running into. Yeah, I think part of that also what you said, Kevin, about data scientists or engineers doing things that are not necessarily in their job description. So a lot of DevOps work of it takes a lot of developer experience to work with something like Dask Cloud Provider or Dask Kubernetes, and Coiled steps in to kind of eliminate the headache there and provide additional security layers, insight into cluster usage and analytics and reporting and things like that. So you have more transparency about the clusters you're using, and you don't have to own the infrastructure. So you spin up the cluster when you need it for the whatever 15 seconds or a couple of hours that you need to run your Prefect flow or whatever other computation you're running, and then it shuts down and you're billed only for the time that it's online.
Right. And Kevin there was talking about sort of machine learning computational tasks. So presumably for GPU-based clusters, this is absolutely ideal.
Yeah, absolutely.
Yeah, we have one user. I've seen at least one user who like spins like a couple of, maybe on the order of like 50 to 100 GPUs, runs them for like 10 seconds, 20 seconds, and or maybe even a minute, and then spins them all down. Coiled can support that kind of workload.
But presumably that keeps the costs down to an absolute minimum, because you're only running the large computation when you need to, rather than having a machine hanging around doing nothing.
Yeah.
You can see that from a cost perspective that makes sense also. So we've heard a little bit about the future of Prefect. What about the future of Coil? What's on the roadmap for you?
Yeah, for us actually, yeah, I'm glad you mentioned GPUs, Kevin. We already support GPUs, but we want to build out more options around that. So specifying the type of GPUs you want to run, having mixtures of CPUs and multiple GPUs per worker. Currently, there's only you can only call workers with one GPU. Yeah, so scaling that out. We're of course, I think 90% of our users are AWS based, so that was our focus in the beginning, but we've recently also launched publicly support for Azure and Google Cloud Platform. So customers can run in their own AWS, GCP, or Azure account. So yeah, those are some of the things we're working on.
Okay. Yeah, sounds really interesting. And I guess with the full range of of connectors that Airbite is going to be providing there, then you've kind of like, you've got the scalability, you've got the heterogeneity, and you've got effectively got the whole package.
Absolutely, and I think, I mean, this is the great thing about the Python ecosystem, right? Things buck in together, and I think that was also yeah, another sort of mantra of when Dask was designed was invent nothing, don't reinvent the wheel, make things that connect into the workflows that people already have, because there's no way you can anticipate. You can't build, I mean, you can, but the choice with Dask was specifically not to build a one-size-fits-all solution.
But I think it's quite compelling, actually putting together a stack that's based on like different providers. We've got a specialist in each area, which obviously contrasts to some of the platforms out there which are just proprietary and buy one and that's your platform. How compelling do you think that is, Jared, is going to be sort of in the marketplace?
I think that's extremely compelling, and that's something that we see really everywhere, even small parts of like ETL pipelines. Like there's a project called DBT that's solely focused on like SQL-based transformations, and it's wildly popular because it's really good at expressing like different views on data sets. And that's just like one example of like just one part of the system where like a problem can be focused on by experts in that area, and they can cover that entirely. And like what we're doing at Airbite is purely just like extracting and loading data. And that's basically it. We're not focused on transformation at all, except for maybe small things like removing certain columns if you have like compliance issues that you need to deal with. But like at our
like sort of personal information, like PII.
Exactly. Yeah. So we're like really focused on only that area, and we want to be able to plug into every system that needs to just like load data from one source to another. And we're seeing a lot of demand for people that they just don't want to focus on that area. It's not their area of expertise. they want to invent nothing, and that's something that really resonates with a surprisingly large amount of our users. Yeah, don't know really what to say. Everyone seems to be going in that direction for a good reason.
Well, I'm interested whether it's going to stay just within the Python ecosystem, or whether, like for example, Apache Arrow is in Rust and you've got bindings in all the language. I'm just wondering whether is that a direction that it's going. So, for example, for Prefect, it's written in a lower level language. But as I understand it, with Orion, it's actually going to be just behind an API. It doesn't actually matter what the client's written in. So that's effectively the same thing, right?
That's true. We are decoupling it from Python such that you can we just need to reconstruct the rules engine, which is very lightweight, and you can reconstruct it in whatever backend language. And as long as that backend language is supported, then you can write your flows in that client. Or actually, you could use like the R interface to call the R, to call the same API also, the REST API. So it will eventually be like easily multi-language supporting.
Yeah, it seems to be maybe the way it's going. So it's breaking out beyond just the Python ecosystem. That's kind of like what I'm picking up on. But
that's actually something that we've focused on a lot, is adding support for multiple languages. At our core, our interface is basically a CLI interface for sources and destinations that are just Docker containers. So you have a Docker container implemented in any language that you want. You provide standard in and receive standard out that follows certain formats. And that's the entire interface for sources and destinations, and allows you to combine them in any way instead of using the like Airflow operator pairwise model where you have to implement a connection between every source and destination. So yeah, being able to like containerize or like provide APIs to get around language boundaries is a necessity. Even though a lot of people are creating connectors with Python because a lot of data engineers just use Python, it's something where we have some people using like Elixir or JavaScript or Java. So yeah, it really makes it easier to plug in if you can plug in with any language.
Yeah, and I guess the other advantage of a heterogeneous stack, putting these best of breed components together, is that you can also use them independently. So you could use Coil or Prefect or Airbite independently of each other if you wanted to, depending on the use case. Just wondering, Richard, could you maybe give an example of how else Coil might be used?
Outside of Prefect, you mean?
Yeah,
or
sort of independently.
Sure. I mean, coiled is a way to spin up Dask clusters, and what you do with them is up to you. So I mean, as long as it can run on a Dask cluster, obviously. Yeah, we see a lot of work, kind of ETL work being done on Dask clusters. But you can also use the Dask ML library for machine learning. So it's the amount of use cases that are on my roadmap to write blogs about is very long because there's so many applications. It's kind of a neutral infrastructure that we're providing.
Yeah.
If I can ask also, you can also just like spin up a Jupyter notebook, coiled backend, and run your data science exploration like that also, right?
True. Yeah, absolutely. Yeah. And one of my favorite projects that I've done so far is use Coiled as a backend to Streamlit. So I don't know if you guys are familiar with Streamlit. It's kind of a I'll see if I can drop in a link.
Front end for data apps, isn't it?
Yeah, exactly. It's kind of a really nice, easy to use, slick data visualization front end package. But if you spin up a Streamlit server, it only gives you 1 gig of RAM. And if you want to visualize the New York City dataset, taxi dataset, you're going to run into an issue. But if you connect it to a coiled cluster, all of a sudden, bam, you've got everything. You've got the resources you need to access that whole dataset and visualize it. So, brilliant. And that coiled cluster spins up in a minute or two. So you've got a really quick turnaround. Yeah.
So I think we're kind of like running out of time a little bit, but I'm just wondering whether, as a close, Kevin, I just wondered if you want to mention Fugue, because I know that you touched on that as a contributor to Fugue. Is that something you want to mention, or feel free to close? Would you have a closing comment you would like to make?
Oh, no need to mention that, since it's just my own personal open source project, but it is related to Dask. It is a SQL interface for Dask actually, and it does work. Like, you can use it to run SQL commands on top of Dask, and I've tried it with Coiled and Saturn, and it does work. But yeah, just to end, I mean, like, I think especially Coiled and Airbite, I think, like, whether or not you use Prefect or not, like, definitely worth checking out. They do enable things, a lot of things very easily for your workflows, like even if you're not using them in the context of workflow orchestration.
Great. Okay. And Jared, any sort of closing remark, like how can people get started with Airbite, or any sort of pointers for folks?
Yeah, the easiest way to get started with Airbite is to just go to airbite.io. You can launch it locally with Docker Compose in just like a couple minutes, or you can sign up for our cloud offering if you don't want to handle any infrastructure.
Okay.
I believe you guys have a demo environment in the browser, right? Which
Oh
is
yeah,
really
let me
cool.
link to that.
That's really cool.
Yeah, maybe pop that in the chat, and what we can do is put all of these posts under the video when we pop the video up on the YouTube channel. And Richard, a little plug for your recent post on Medium. That was good reading.
Sure. Sure. Yeah, I mean, that's a great example. I think the example that Kevin shared that's in our docs is kind of using Prefect as using Coiled as a backend for your entire Prefect flow. But if you want to only use Coiled for tasks that are computation heavy, you can do that by following the code that I just dropped in to the chat. So that's a great example of really only spinning up the cluster and paying for it when you're trying to run a heavy computation task.
Okay, brilliant, amazing. Well, many thanks to you, Kevin, for a great presentation. I'll just swap to the slides. Thanks to you, Richard. Thanks, Jared, for joining us this evening. We do record all our videos, and they are there up for replay. Bristech/videos. It's actually on the YouTube channel. So I'll be posting this video in the next couple of days. The webinar that you mentioned there, so to see Matt Rocklin and Chris White, it's sort of rather late British summertime, but yeah, if you fancy catching that, it's on the 26th, and we'll repost all those other webinars. The next event we've got going is on the 4th of November. We've got GPU programming with Rapids and Python. So Jacob from NVIDIA is going to be getting us started with GPU programming. So a nice overlap with tonight's topic. And thanks to our sponsors, to GoCo Group, which is now Future Publishing, Oracle Cloud, Storm, and Over Energy. They make it happen financially. So thanks very much for sponsors. And thank you for joining us tonight. Thanks. Bye-bye.
Thank you.
Bye-bye. Thank you, guys.
Bye. Thanks.